Hello, everyone, and welcome to PlatformCon Platform Tech Track. A quick heads up that I am available on PlatformCon Slack during and after the talk. Let's get started. This talk is Do Not Click Ops Your Data Infrastructure. My name is Dewan Ahmed. I'm a developer advocate at Aiven. We build and manage your data infrastructure based on open source technologies so that you can focus on your critical applications. I'm from the beautiful New Brunswick, which is in the east coast of Canada. For the last 10 years, I've been focusing on application and data infrastructure. Outside of work, I'm a pro bono career coach. That means I'm helping students and new grads to start a career in tech. Now, before we had all this automation and infrastructure as code tooling, things were very simple. We created a service ticket by clicking on a button, and then someone from the ops team were assigned that ticket. They gave us a VM, and that seemed like magic. Even in the era of cloud and automation, we click buttons to have some services running. Maybe this is for some proof of concept, but there's only so much we can do by clicking buttons. So in this talk, I hope to touch on the principles around infrastructure as code, some of the objections I hear with infrastructure as code approach, and give you some ideas on how you can get started using infrastructure as code. When we talk about infrastructure, typically we talk about application infrastructure. So let's say you lay your core network, the VPCs, and you have an abstraction on top of that, maybe security group, and then you create your VM. You put a load balancer in front of the VM and you target your DNS to that load balancer. And finally, let's say you have a CDN for faster delivery. But why do we build applications? To move data. That's the sole purpose of our applications, whether it's your mobile banking application or an application that's moving data between your enterprise data warehouse and a cloud data warehouse. Our applications move bits or JSONs more commonly. So that's why it's important to talk about the data infrastructure as well, besides the application infrastructure. So what's data infrastructure, you might ask? Let's say your streaming platform like Kafka. How about the relational database you have like PostgreSQL or the NoSQL database? Or you might be using all of them combinedly. You might be having some specific networking settings like VPCs for this data infrastructure, or you might have a monitoring dashboard specifically for one of your databases. How about the security configurations? All of these are part of your data infrastructure. So it's important to consider your data infrastructure the same way we handle our application infrastructure. So that's why let's talk about infrastructure as code and its principles. So infrastructure as code is a concept that says managing or provisioning your infrastructure should be through code rather than via manual process. And let's see some of the principles. So the first principle is around reproducibility. That means your infrastructure as code tooling should handle the build and rebuild of the systems rather than your engineers arguing about choosing the host name. So it should be easily reproducible. The second one is around repeatability and automation. That means if you create one service once, it's easy to click a button or run a script. But what if you need to ensure idempotence and create it 20 times? So then neither the clicking of a button or a script would be handy. So that's why the infrastructure as code tooling handles this repeatability aspect so that even if you create 20 different services, it's taken care for you rather than duplicating the effort. The third infrastructure as code principle is around disposability. That means the underlying hardware for these cloud providers are disposable. It's the cattle versus pet approach. That means the failure of the hardwares are not a matter of if, but when. Service continuity in the cloud era depends on how we handle this disposable infrastructure. Let's talk about the fourth principle, which is consistency. If you have your test environment and your production environment, and the applications that run in test environment run in a completely different settings, let's say the vCPU, the memory are allocated in a different way than what's running in production, how you can predict the reliability of your applications? So the environments should be consistent. And finally, the design of the system is always changing. That means that one way to ensure that the system can be changed and changed quickly is making frequent changes. And if you do that, change is no longer dreaded but expected. Now, there are some challenges around infrastructure as code approach as well, and most of these are valid concerns. The first concern is resistance to learning. That means if something is working fine, why change it? Now, some questions around this approach is it might be working fine now, but you might hit a bottleneck or some scalability issues in the future. So rather than having your production down and then try to fix it, it's better to vision the long-term solution and think if infrastructure as code tooling is the right choice for you. The second and third points are similar, which talks about configuration drift and duplication of work. So you might be trying to use infrastructure as code tooling, but at the same time, some engineers are clicking the button to make changes directly in production. Some engineers might have some scripts lying around, and all of these are creating configuration drift and also duplication of work. But if you're trying to move towards infrastructure as code tooling, it's understood that at some time there will be some overlap. It is perfectly normal. It's important that you have a strategy in place to retire those existing practices and move towards infrastructure as code tooling approach throughout the organization wherever it makes sense. The fourth question or concern is around security. Now, according to a 2020 report, nearly 1 in 2 modules to build resources for major cloud providers were misconfigured. Now, while the stat is true, we have to understand that these modules are just like code we get from the internet. If you get a piece of code from Stack Overflow, you probably will not run in production without verifying that it's properly configured and it passes all the checks, especially the security checks. So we have to have the same approach for these tools as well. In this case, it's a Terraform module. And the final concern with infrastructure as code is handling unicorns. And you might ask, Dewan, what's handling unicorns? Glad you asked because I have an entire slide on that. Now, this unicorn is databases or relational databases more precisely. And the concern is mostly around how do we do X without downtime. So how do I perform a version upgrade without downtime? How do I prevent a version upgrade without downtime? And if I make major configuration changes, how do I do that without downtime? So let's talk about the first one first. How do I provide, uh, how do I perform version upgrade? So if it's a major version upgrade, there are very few providers, almost no provider will guarantee a zero downtime. So imagine that if you didn't use infrastructure as code tooling and you clicked a button to upgrade your database, would you have zero downtime or you ran a script? So it's the same thing because it's almost calling the same API. So if you did have zero downtime with not using infrastructure as code, then you should be able to handle some downtime using an alternate approach. Now, there would be some design decisions or some services that offer you minimizing the downtime and maintenance window, but absolute zero downtime for major version upgrade is very rare. Now, to prevent a version upgrade, Some Terraform, and again, I'll introduce Terraform in a future slide, but Terraform is an example. So if you would like to prevent version upgrade, some Terraform providers have flags like allow version upgrade. And if this flag is set to false, then there won't be automatic version upgrade. And finally, there are a lot of configurations, and some configurations will cause some downtime. So it's important that you analyze that which configuration changes can happen without any downtime and which configurations will cause some downtime. So maybe just like the version upgrade, you can choose a maintenance window or expect some downtime for these changes. So Terraform is an open source infrastructure as code tool that lets you define both your cloud and on-prem resources. The code is very human readable, and you can version control the code, reuse the pieces of code in terms of modules, and share it with your engineering teams across the board. With this, you can manage any infrastructure, or whether it's an application infrastructure or data infrastructure, track changes because it's version controlled, automate changes, and standardize the configurations. One quick note is you don't have to use Terraform. It could be some other tool, but as long as you're following the principles and best practices, you should be fine. So this is Terraform is used as an example here. Terraform creates and manages resources on cloud and other platforms using an API. And providers enable Terraform to work with virtually any platform using an API. So, for example, Aiven has a Terraform provider which lets you create Aiven resources using Terraform. And Terraform community has more than 1,700 providers to manage thousands of different kind of resources and services. Now let's check out how a piece of Terraform code looks like. Now in this block of Terraform code, we are creating three PostgreSQL resources on different cloud and different regions. Now the code itself is easily readable by a human as well as by a machine because we can exactly see that what kind of resources are being created. This is using Aiven Terraform provider, which creates an abstraction layer on top of the cloud providers. So you can target any cloud provider you want out of the major five cloud providers and pick a region, pick some settings. And once you run that, your resources would be created. And this is one of the benefit if you're thinking from the multi-cloud aspect of using Terraform. That means your engineers now don't need to learn another new tool. As long as they're familiar with Terraform, they can target any cloud providers, specific resources within these cloud providers, and be able to handle the infrastructure changes. The next part is how do I start? So the first step is the research part. There's no silver bullet. You and your engineering teams have to ask if this tool is right for your business case. The second point is around awareness. Remember, the one of the challenges is the resistance to learning. So you have to have awareness within your organization to ask if you're ready for this change. The third point is the absolute basics and the concepts. If you know the principles and the fundamentals of the infrastructure as code tool you chose. I'll link a resource at the end of this talk on the principles and patterns for Terraform or infrastructure as code. Number four, let's do a pilot. I think that's the best way people learn and they have some confidence on a tool when you do something fun, something small, but see the tool in action. And the last one is go all in. Just kidding. Don't go all in on anything. You have to have a strategy. The tool might be applicable for a subset of your business, maybe not everywhere. So it's important that you roll out where it makes sense and you also have a fallback strategy that if things go bad, how do you fall back and how do you revert those changes? So, in this talk, I covered the principles around infrastructure as code and raised some questions that why we need to handle our data infrastructure similar to application infrastructure. I covered some of the common objections around infrastructure as code and gave 5 steps on how you can get started. I thank you for your time, and here are some resources if you'd like to learn further. Thank you for your time.